Okay, folks, welcome back. Here we go. Today we're going to be looking at velocity and other rates of change. Now, to those of you after our last lesson, which was very, very heavy on techniques and how to do things, today we're going to be pretty much emphasizing applications. Okay, how do we use this? Those of you that have been through the lovely land of physics, you're going to be right here at home. And those of you that have not had physics, don't worry, it's not incredibly difficult. So here we go. Well, there's a couple things that we need to review. Okay, first off, your average rate of change formula. Again, assuming that I have 2 points, some point X and some point A, your average rate of change is just going to be f of x minus f of a over x minus a. And as we get closer and closer, our average rate of change is going to actually approach our instantaneous rate of change. Our instantaneous velocity, we're going to be using what is sometimes called the difference quotient, or the definition of the derivative. Again, what we have is our velocity is talking in terms of positions. So what we have is our f of x function gets us our position, and our x value is just some time mostly. And then we have speed. Now, this is something that's going to be a little bit new for some of you, but it makes pretty much common sense. So if somebody decides that they are going to try and break the speed limit, trying to blast by Welsh Elementary School by, instead of going at 35 miles per hour in drive, they're going to go in reverse and think that they won't get a ticket. Sorry to disappoint you, they're still going to pull you over, because even though velocity does have a positive and a negative element, speed is just the absolute value of it. So if you get pulled over because you're going 40 miles an hour in reverse, you still get a ticket because it is a speed limit, not a velocity limit. Okay, next up, we're going to talk about the word acceleration. Now, acceleration is how fast your velocity is increasing or decreasing, which is why when you hear, some people standing on the gas, they say they're pushing the accelerator. The accelerator is the pedal that makes you go faster, and if you keep your foot on it all the way, not only are you going faster, but the rate at which you are going faster is also increasing, especially if you have a hopped up car. Anyway, so when we're talking the acceleration, it is talking about the derivative of velocity. And so what we do is we just take the derivative of the velocity to get there, or we take the second derivative of what is the position. And I might just comment real quickly, the position function is defined by s, the velocity function is defined by v, and the acceleration is defined by a. And they're all in terms of time generally. Okay, next up, so let's consider our graph of displacement, okay, otherwise known as, well, distance traveled. Or to borrow a phrase from Mr. Coos, displacement is when you go from displace to displace. That is your displacement. Where did you go from and to? So keep that in mind. So I've got a graph of displacement. My average velocity can be found by taking the change in position, which is going to be vertical in this case, over the change in time, which is horizontal. So I just say it's just delta S over delta T. Again, we talk about the distance or position being in terms of S. Okay, and so yeah, that should look pretty familiar to you. That's just another way of writing things. Okay, but remember, your speedometer doesn't measure average velocity, it's instantaneous velocity. So therefore, the only difference between what we had there and what we have now is this time we're looking at the limit approaching 0 in this case. Anyway, and please keep in mind that's your velocity at one moment in time. You could find your average velocity, which the state of Illinois has promised they will never use it to get a ticket for you by trying to find your average velocity, because technically what they could do is find out what time you got on to I-355 and how far you went and do the division, and they could issue you a ticket because you went 65 miles an hour. Well, but we'll see. Anyway, in summary, velocity is the first derivative of position, speed is the absolute value of velocity, and acceleration is going to be the derivative of velocity. Okay, so we also need to talk about your relationship between a position graph, a velocity graph, and acceleration. So I have right here a distance and time graph. So what I'm looking at is, you would agree that my first derivative, my derivative of this function, is going to be, well, let's see, positive here, because my slope going from this point here to this point there is just going to be a positive value. But you will also notice that I have it concaving, or it's bending. It's bending upwards. Now, I know most of you guys covered that in pre-calc. When you have concavity being positive, we refer to that being the second derivative of the function. So I'm going to say, not only do I have a positive velocity, but I know that my velocity is getting more positive there. So I'm going to say that my acceleration is positive. Okay. Next up, I'm going to say, well, my velocity here is going to be a positive velocity, but notice I have no bend. So therefore my acceleration is 0. I may have a velocity of 50 miles an hour, but I'm not changing my velocity, so I have no acceleration. Then I'm looking at this situation here. This again is just a graph of distance versus time again. Here in this stretch, I have a positive velocity still, but please notice what's happening. My velocity, which is my slope, is becoming less positive. And what happens here? Well, I've pretty much put on the brakes, so I now have a slope of the tangent line is going to be 0. So when you are looking at the derivative of distance over time, you're going to say, well, when I have a velocity of 0, I've stopped. And now you can see that, well, now my velocity has become negative. So I'm going in reverse. And take a look, it's becoming more negative. Okay, so my acceleration is negative. And then I'm going to be talking about how my acceleration is going to be 0 here, because it's maintaining that same speed, that same negative velocity. And then what's happening here is I'm either taking my foot off the gas, or I'm putting on the brakes, because what's happening is my negative velocity is becoming less negative, and I'm back down to a velocity of 0. So you can see that I went from position 0 up to some position here, and then I came back towards us. That's something that we will spend a little bit of time going through in class a little bit later. Okay, so before I do that, I also want to take a look at one more thing here, and let's take a look here. Now remember, your derivative represents the slope of the graph, or the rate of the change. So the rate of change of position is given by the particle's velocity, and the rate of change of a particle's velocity is called acceleration. So we're going to run through a couple words here. When we're given something, we're going to say that the position is going to be my original function. Here's an example of a position function. Then I can talk about my displacement. That's my change in position. Okay, so what I need to do is, if I'm trying to find my change in position after 3 seconds, I need to plug 0 into this function, and I also need to plug 3 into this function to find out what the difference is between these two. Okay, and that's really a key point here, and you need to be careful. When you're asked to do the displacement for a 3-second period, we need to substitute stuff in. Okay, next up, the average velocity is just going to be the slope between 2 points. So what I do is I just plug it in and I divide by 3. So I would, in this case, to find the average velocity after 3 seconds, I would have found what my position was after 3 seconds and subtracted my original position, which it would happen to be 0, and then I divide by 3 minus 0. That's just my average velocity. Okay, and I'm hoping people are okay on that. So, questions that people have? Hopefully not. Let's move on. Next, again, velocity is going to be generally the average between 2 points, but if I've got instantaneous velocity, it's the velocity at a given time using just the first derivative. A velocity could be positive or negative. Sign implies direction, and all velocity will have a sign and some sort of numerical value. Again, the speed is the absolute value of velocity. And we can talk about the first derivative of a function is going to be the rate at which the position changes. And the second derivative is just going to be the rate at which the velocity changes. Okay, the rate at which the position changes we call velocity. The rate at which the velocity changes we call acceleration. Okay, once again, give you guys just a second, and you can pause this if you need to. Let's move on. So if I ask you to do this, we could actually do some computations on this and plug stuff in. So my displacement after 5 seconds, how would I go about doing that? Well, I'm going to have to substitute in 0, and I'm going to also have to substitute in 5. And that should be able to get me what I'm looking for on that. Okay, so I'm going to say f of 5 minus f of 0, which is going to be 20 minus 0, which is 20 meters. Okay, next up. Let's scroll down a little bit so I can click on something here. What is my average velocity in between 2 and 5? What I need to do is I need to find my displacement and divide that by the difference in time. So I'm going to say I need to figure out what s of 2 is, which ends up getting me 2, and s of 5 is 20. I take the difference between these two, and I take the difference between the two numerical values, and I'm looking at 6 meters per second. Just to let you know, it's one thing that I'm going to warn you about real quickly. We believe in the imperial system in math. I know physics and your science don't believe that the imperial system exists. They really want to convert everything into kilometers. Unfortunately, we do live in America, and we do everything in miles, so don't be surprised if things change a little bit. What is my instantaneous velocity at 2 and 4? Again, using this same original function. Well, if I'm trying to find my instantaneous velocity, I just need to take the derivative of that function, which is just going to be something that you use your power rule to get, and then you just substitute 2 in here, and then you substitute 4 in there. So s prime of 2, or v of 2, is going to be -3, and s prime or v of 4 is going to get you 9. Okay, let's see, I think, and you can also come up with various things and finding speeds. Again, just need to take the absolute value there on that. Okay, and we could do another example, but honestly, what I would like to do is just take a look at this. Okay, this is the position graph. So if I was to start asking you questions here, I could try and say, when is the particle moving right? Now remember, right in this case, we would be referring to as moving in the positive direction. So I'm looking for those places where my slope is positive. So I'd say in between 2 and 4, and in between 6 and 7 would be my answer on this one. So in between 2 and 4 and 6 and 7. Next up, when is the particle moving left? When is the particle moving left? Well, I'm looking for when my slope is negative. So I'm going to say in between 4 and 6 and in between 7 and 9. Okay, and then finally, I'm going to say when is the particle standing still? I'm going to say when is my derivative equal to 0? That's in between 0 and 2. All right, and let me do one more here, and this time it's the graph of a velocity graph. So I could ask you the same questions. When is my particle going to the right? And I'm going to say when my velocity is positive. Well, when is my velocity positive? Because this is a velocity graph, I'm going to say my velocity is positive when it's above the x-axis. So I'm going to say in between 0 and 4. My velocity is negative in between 4 and 9, and my velocity is 0 in between 9 and 12. On the other hand, If it's a position graph, I need to look at the slope in order to determine when the velocity is positive, negative, or moving right or left. So I'm going to say I have a positive velocity in between 0 and 3. I have a negative velocity between 3 and 5. I have a 0 velocity in between 5 and 7, and I'm back to a positive velocity in between 7 and 9. Okay? Well, folks, let's be honest. At this point, I'm pretty much done, and I'm hoping that that helps.